Okay, so if I was going to take x to the second times x to the third. X to the second times x to the third. What do I do when I'm multiplying? What do I do with the exponents? So I get x to the fifth. When I'm doing raised to a power, x to the third raised to the second power, then what do I do with the exponents? I multiply, so I get x to the sixth. So when I have a bunch of stuff inside the parentheses and it's raised to a power, you have to distribute the 3 onto everything inside. So I get 2 to the third, x to the third, and y to the third. And then what is 2 to the third power? 8, Mrs. Archer. Bless you. So you get 2 times 2 times 2, which is 8. Two times 2 is 4, times 2 is 8. So the division works like this. If I have x to the fifth over x to the second, I'm going to subtract, and that gives me x to the third. But what if this is reversed? If I have x to the second over x to the fifth. So I get x to the 2 minus 5, which is x to the negative 3. Can I have negative exponent? No. Not if you want to get it correct, you won't. So if you have a negative, this is like x to the negative 3 over 1, right? The negative 3 means wherever it is, and in this case it's on top, right? Wherever the negative is, it means you have to move it to the other. So I'm going to move this down, so I get 1 over x to the third, and it would become positive. Is that okay, Colin? You're looking a little afraid. I haven't even worked a real problem yet. Can I go on? So, okay, so I'm subtracting, right? So the first thing I'm going to do is I'm just subtracting. It's division. So I get 2 minus 5, which gives me x to the negative 3, right? And so since it's x to the negative 3, I'm just going to put it over 1. And the negative means it's not happy where it is, so it wants to go to the bottom instead of at the top and become positive. So you just flip it. Well, you don't really flip it, but you have to move this to the bottom. And in this case, you can't just leave it with nothing on top now, so I put a 1 there. Yeah. Is that scary? Is that scary? No. Well, if there's a number there, if it was 2x to the negative 3, so if there was a 2 here, this would be a 2 over x to the negative. It's not always a 1. So like if there's a 2, okay, first of all, you guys stay off your phones. Just because I'm explaining doesn't mean you pick up and check your messages. So if there's a 2 in the problem to start with, the 2 is going to stay on top, and just the negative exponent goes to the bottom. If there's nothing there, you fill in a 1. Okay. Here's something scary, Colin. Are you ready? Okay. Anything to the 0 power is always 1. So x to the 0 power, it's 1. 100 to the 0 power is 1. 1,000,000 to the 0 power is 1. Because I said. It's a rule. It's no exponents, so it doesn't exist, so it's a 1. Okay, so the last one I want to talk about is when I'm dividing. and I raise it to an exponent. So first of all, when you raise to an exponent, you multiply. So I'm going to get x to the 4th over y to the 6th. All right, let's do some real problems. Those were pretend problems. All right. 8 times 2 is what? 4 times 2 is 8. What do I do with the exponents when I'm multiplying? Add, so I get b to the what?
5.
So on number 2, 3 times 5 gives me 15, but I have n and then n to the 2nd. So this is like n to the 1, so 1 plus 2 is 3. When I raise to the power, you're going to multiply, but there's a number here, so you have to distribute the 2 to that number also. So I get 2 to the 2nd, n to the 4th, and 2 to the 2nd is 4n to the 4th. So on the next one, I get 4 to the 4th, m to the 8th. Yeah, what is it, 256? 16 times 16. Now somebody pick up your phone. Is that 256? We're going with that. If it's not right, it's Mason's fault. Okay. So next we're using the quotient property. The quotient property means you're subtracting. So do I do anything with the 2 and the 3? Nope. X to the 3rd minus x to the 2nd gives me 1x. It's positive, so it went on top. So here's the example I was just working. I can't do anything with the 2, so the 2 is going to stay there. So I get r to the 2 minus 3, which is r to the negative 1. And that would be on top. But we can't have a negative exponent, so where do I have to move that? To the bottom, and it becomes r. But now there's nothing on top. So just put a 1. It's not complicated. So I have v to the 2nd, I have 2 to the 4th power, and v to the 16th power. So 2 to the 4th is like 4 times 4, so that's 16. And then here I have v to the 2nd minus 16, which is v to the negative 14. And what does that mean? That's on top, so I want to move it to the bottom and make it positive. Where are you guys lost? Scoot it over which way? You don't even talk because your head still hurts probably, right? Like you're not even going to remember asking this question tomorrow. Does anybody else have the question other than him? How did you get the negative 14? All right, I'll answer you because you'll probably remember. All right. So look. Here I have v to the 2nd on top and v to the 16th on bottom. It's a division problem, so you subtract. So 2 minus 16 is negative 14. That's on top, but I don't want a negative exponent, so I moved it to the bottom. There's nothing here, so I'm going to add the 1 on top. So when I raise to a power, I multiply, so I get v to the 8th over 2v to the 4th. And now I'm dividing, so what do I do with my exponents? So 8 minus 4 is 4. And that stays on top, right? It's positive, so it's going to stay on top. V to the 4th over 2. It's just like this. All right. So I have to distribute the 2, so I get 2 to the 2nd, a to the 8th over And on the bottom, I have a to the fourth and a to the second. So I add those, and what does that become? A to the sixth. So 2 to the second gives me 4. 8 minus 6 gives me 2. So you get 2a to the second. What's x to the 0 power? 1, because I said so. 2 times 2 is 4. 2 plus 2 is 4. So 1 over 4x to the fourth. So number 11. 2 times 4 gives me 8. Now I have to add 4 minus 2 gives me 2. Is it positive? So it stays on the top. So it's n to the second. Okay, so for the next one, so I have a negative 2 here, right? And I have to distribute that to everything inside. So I'm going to get 2 to the negative 2. What's going to be the r? So it's negative 3 times negative 2. That gives me positive 6. And then on bottom, I have 2 to the negative 2, r to the negative 2. Okay, does everybody see that? Okay, so before I go any further, 2 to the negative 2 divided by 2 to the negative 2, those cancel, right? Because those are the same, so they cancel. So we can cancel those. Now, the r to the 6th and r to the minus 2, I'm dividing. And so what do you do with your exponents when you divide? You're going to subtract. So here I get 6 minus a negative 2. So minus and minus becomes positive, and we get r to the 8th. Look how much fun you guys are having. I know. This is awesome. I don't know why you're moaning. You're having fun. Stop rolling your eyes over there. You were having fun. Kind of you were, a little bit. So 2 times 2 on top gives me 4. And what do I do with the exponents? Add. So I get n to the 5th. And then I have n to the negative 4 raised to the 3rd. Well, that means to multiply, right? So that's n to the negative 12th. So on top I have 4. And now this is division. And what do I do with division? So I get n to the 5th minus a negative 12. So that becomes n to the 17. Is that on top or on bottom? It's on top because it's positive. So on number 14, on top, negative 2 plus 2.
0, 1.
Anything to the 0 power is 1. So I have 2 here. You have that 2 left over right here. The p is 1. Negative 2 raised to the negative 1. It's 2. It's positive. Where does that go? Top.